data elements? Data elements are the building blocks that you drag and drop into a workflow to capture the needs of your specific data collection process. In this video, we'll review the numeric and decimal data elements, basic configuration properties, and how these elements can detect defects in a workflow for heightened visibility and traceability. Let's get started. You can locate both the numeric and decimal data elements under the Self-Managed tab in the Workflow Builder of the web app. Simply drag and drop the element into your workflow. On the right-hand side are the element's properties. Properties are used to configure your data element and are split into two sections, common and additional properties. As you can see, properties for numeric and decimal data elements are nearly identical apart from the multi-line property being replaced by the decimal places property in the decimal data element. Use decimal places to limit the maximum digits that can be entered after a decimal point during data collection. Under Common Properties, provide a descriptor for your element using label. To eliminate repetitive data entry when applicable, set a default value using default text, or utilize placeholder to add things like instructions to your data element. By default, all elements are set as a required field and can be toggled on or off at the bottom of the Common Properties list. You can also set the unit of measurement using the unit property located under Additional Properties. A unique aspect of the numeric and decimal data elements is the ability to detect defects when configured properly. There are three other distinct elements that allow for defect detection, collectively known as the defect detection data elements, and include grid list, Silvac for gauges, and torque. Now, how does defect detection work for numeric and decimal data elements in Digital Clipboard? When the minimum and maximum value range is set, any number entered outside of that range is flagged as invalid and cannot be submitted as data. Combined with the configured specification limits from the high-low limit properties, values within the specified range are registered as good values. Anything outside of that range is flagged as out-of-spec inputs that can be applied to action workflows for corrective actions and notifications, which will be covered in a separate video. Both sets of properties are optional for the configuration of defect detection and only need be set for the data being collected. Take temperature check, for example. If a defect occurs only when the temperature is over 100 degrees, only high limit needs to be set, leaving the low limit, minimum, and maximum properties empty. To configure your numeric or decimal data element for defect detection, first set the maximum and minimum number properties to dictate the valid range of data entry within the scope of the item you'd like measured. Under Additional Properties, locate the high limit and low limit properties to set the desired specification limits of measurement. Now let's see it in action. Using temperature check for this example, entering in a value above the maximum valid range results in an error. When corrected to a number within the acceptable range, a green checkmark appears. Inputting a value between the limit and the maximum or minimum acceptable range alerts the user that the data entered is above or below the specified limit and is flagged as a defect. To learn more about data elements, check out our video library or knowledge base on our website at datamite.com.